right, hello people watching this video. This is Trig Chapter 5 review. We are starting with number 9, and we're just going to book right along. 9 and 10 say that the parent function for this is 3 to the x power. What kind of function is that? Exponential. What kind of exponential? Growth or decay? How do you know it's growing?
Either one.
Not necessarily positive.
Oh, it's greater than 1.
It's greater than 1. 3 is like multiplying by 3 each time, so tripling it every time. If it's a number smaller than 1, like 1/2 or a third or a fourth, whatever, then it's going to be an exponential decay because it's like splitting in half, etc., right? They want to know what the transformations are, which is like up, down, left, right, vertical stretch, vertical compression, those type of things, okay? So here we have 3 to the x power is my parent, so you don't have to like determine what the 3 is doing. How many other things are happening to it? 2. The negative and the 4 are separate. Which one is happening first?
Simultaneously.
They're happening simultaneously. You can switch these two around. The 4 and the negative are happening at the same time. Which one would you like to do first? The 4. What's the 4 doing? Vertical stretch by 4. Vertical stretch by 4. What's the negative do out in front? Over the x-axis. Okay. That is the negative and the 4. If you switch those two around, I won't count off for it. Otherwise, I might. Number 10. Okay. You have 3 to the x power, still the parent function. How many things are happening? 2. The 4 and the 7. Which one's happening first? The 4, because if I would plug a number in for x, you would add the 4 to it first, right? So how does the 4 move it? Left and right, okay? Because it's plus, we're moving it to the left because it's the opposite, right? What's the minus 7 do? Down 7, okay? So my exponential function, like rather than him like touching here at 1 and doing this, he's going to go to the left 4 and down 7. You don't have to graph this, but he'll look like this instead, like that. Right? Left 4, down 7. Got it? I'm going to erase that. But anyway, that's what we're talking about, like how you can graph him. Okay, 11 through 13, as well as some of the ones on the back side, 30 and 31, you're going to have questions that are going to require your note card. Make sure you have your note card. If you do not have a note card filled out, we did that like halfway through the chapter or a couple sections ago. If you don't have a note card, let me know. I will get you a note card, and then you can copy off of somebody's. Okay? Or I can, like, go back and share that video with you if I have a video of us filling out the note card. I think I do. Okay? All right, so 11. Here we go. You are investing $5,000. Let's just write down. What would that be? Principal. P is 5,000. I'm just going to dissect. I don't even know what the equation is yet, but we'll get to that. Okay? You are investing $5,000 for 5 years. That is time, T, at 9% interest. Rate, 0.09 if you move the decimal, okay? How much more will you make if interest is compounded continuously rather than if it's compounded quarterly? So we've got to do this twice. Okay? So I'm going to do continuous compounding here. I'm going to figure that out, and then I'm going to do compounded quarterly. Okay. All right. What's the formula for continuous compounding?
What?
Continuous compounding.
A equals
PERT. P-E to the RT power. Okay, so let's figure out what that is. We are solving for the after amount. That's what we don't know. Okay, the principal's 5,000. This is just a plug into your calculator type thing. E to the 0.09 times T power, or 5 power. Okay, 0.09 times 5 is 0.45 if you want to just do that and not like plug that into your calculator. Whatever, I don't care. What do you get for an after amount if it's, which one's going to be higher, by the way? PERT's going to give you the higher number, right? You're going to make more money the more you compound. And if you're compounding continuously, that's going to give you more money than compounding quarterly. All right, what's this give you?
78.41.
78.41 and
56.
56 cents. Okay, if you type that all in. All right. Okay, so compounding quarterly should give you a little less than that. Compound quarterly, A equals, it's like P times 1 plus R over N to the NT power. And the only thing I don't know right now is what N is.
4.
N is 4. Okay, so 5,000. 1 plus 0.09 divided by 4 which is an ugly number, whatever. And then we have 4 times t power 5. Okay, some of that stuff I would try to do in my head, like 4 times 5 is 20, I know for sure. I don't know, 0.09 times or divided by 4 is a little uglier than that, but whatever. Okay? Try typing that in and see what you get. It should be a number that's a little less than 7,800 or 7,840.
7802.55.
7802.55. Okay, now it's not asking for both of those numbers. It says how much more will you make if you're doing this versus doing this. So what's that mean? Subtract them, like maybe like $38 and something cents. I don't know.
$39.01.
$39.01. Perfect. That's the final answer. Make sense? Ha, because it's cents.
Ah,
You're so funny. You're so funny, Mrs. Comacher.
I'm slapping my knee so hard.
Slapping your knee so hard. Okay, happy with that? Questions about that? That wasn't too bad, right? You're not solving for anything. You're just solving for the after amount, whatever. Okay? All right, population of Potterville is decreasing at an annual rate of 1.5%. Okay, so R is 1.5%, but I'm going to put it as 0.015. You move the decimal, right? If the population is 38,500 now, what does that mean?
That's our principal.
That's our principal, 38,500. Okay. What will the population be 7 years from now? So that means T is 7. What are we finding? A. We don't know what A is. Okay. Okay. What formula do we use? Do we use PERT?
No, the first one.
Annual rate
Yeah, but
is annual compound interest, right? Yeah. So A equals P times 1 plus R to the T power. It's like the compound one, but you're not dividing by N. You really actually are dividing by N, but N is 1, right? So that doesn't need to even be there. Okay. P, 38,500.
Isn't it 1 minus R instead?
Oh, is it decreasing? Yes, you're right. Ha ha ha. Minus R. So 1 minus 0.015 to the T power, which is 7. I mean, if you want to go ahead and do the middle part in your head, you can. 38,500. 1 minus 0.15 is 0.985 to the 7th power. That's all you have to type in. Or not. I mean, you can type it all in at one shot. So our population should be less than 38,000, right? We're decreasing in value. Okay, this is an exponential decay function because this number is less than 1. We're going down in value. What we got? Anybody who typed it in?
What do you want?
What?
34,635. Well, that is not accurate
Why?
because, like, if you have a big family, like, families are gonna move and leave together, so
Probably.
you can't actually.
Probably. Yeah. Yeah. But that's why it's decreasing at an average rate of 1.5. So yeah, we might be plus or minus a little bit from there, but like on average, that's how many people we should have ish.
And ideally, like,
Ish.
the last 10,000 people, they're all gonna leave faster than the first 1,000 would.
True.
So.
True. But we haven't gotten
this
that
is
far
not
yet.
a
We haven't
very
gotten that
good-
far yet.
Kyle, shut your mouth.
That's why I said when we do these exponential functions, it's not going to be exactly the same. Like it's not going to follow an exponential function perfectly. Your R value, you remember like when we did R and R squared? It will probably never be 1 exactly. It'll be like 99% or 98%, right? Something close to that, but it'll never actually be 1 perfectly because of those anomalies that happen, right? But in a perfect world, if it's decreasing at an annual rate of 1.5, it should be about that much. 13. I don't have to guess what the formula is. Half-life.
I can't do it. Where's my paper and it's ripping it?
No, I'm making airplane.
she's
You don't know how to make
making
an
arts and
airplane,
crafts.
I just watched you.
Half-life of carbon-14. All right, I'm gonna write my equation over here. A equals B times 0.5 to the T over, what do we use, K? Is that it? That's what we have? Okay. Half-life of carbon-14 is 5730. What's that?
What's your half-life?
That's your half-life, which we call
Okay.
K. 5730. You have that written on your note card, right?
Yeah.
Okay, because that's the one that they use a lot. How much carbon-14 remains? So what are we solving for?
Your after amount.
After amount, that's what we don't know. Okay, remains if our original is 16. So what's 16? P, and the time is 12,000. Let's do some guesstimations here. Ready? If it splits in half every 5,730 years, and it has been 12,000 years, how many times has it split in half-ish? A little over 2, right? It's already split in half twice, okay? If I'm starting with 16 and it splits in half, it should be down to 8. If it splits in half again, it should be down to 4. It should be a little less than 4. True? A little less than 4 grams is what we're at now, right? Because it's already split in half twice. Does that make sense? That's how much time is left. All right, okay. So after 16 times 0.5 to the, what do we have, 12,000 divided by 5730. Whatever that is. What'd you get? 3.74 grams is what we have. But does that make sense? Like we can do that kind of in our head-ish and figure out like, is that a rough estimate good? Is that close to being correct? Yeah? Good?
Yeah.
Okay. 14 through 17. These are going to be the easy ones. Hopefully.
Those are not easy.
These are easy. Okay? Translate each log function to an exponential and vice versa, right? To the alternate form. Okay? Let's talk about 14. Is he a log or an exponential?
Exponential.
Exponential. So we have to make him a log, right? That's all we have to do is switch him around. Okay? What's the base of that log going to be? Log base what?
E.
Log base E of?
I was right the first time.
Log base E of what? 756 equals? 6.628. Now, please don't leave it like that because what is log base E? ln. So this is actually ln 756 equals 6.628. Got it? That's done. We're not solving anything. We're just rewriting it. Got it? These are the easy ones. All right? 15. Let's bump over here. Okay. Is this a log or an exponential? It's exponential. So we have to make it log, right? What's the base of the log?
10.
Log base 10 of?
7.118.
What are you talking about?
you doing?
He's not listening.
15.
I want a different one.
A equals C plus D. Now, if you want to, you don't have to rewrite it. I will accept that as an answer. But if you want to, you don't have to put the 10 because anytime it has a no number there, we assume that it is 10, right? So if you want to just put log T equals C plus D, I'm fine with that, right? Because that's technically what log base 10 is. I don't care. Please don't leave it as log base E and switch it to ln. But if you want to just leave the 10 there, that's fine. Okay? Ooh, I'm making everybody dizzy. Here we go. 16. ln. All right. This is, here we go. ln of 1, 2, 3, 4, that's weird, equals 7.118. Is this a log or an exponential function?
Log.
It's a log right now. We have to make it exponential. That just like helps to sort it out in my brain, okay? But for an exponential function, I need a base. What's the base going to be? E. Okay, so first, I like to write ln as log base E, right? Okay, so now I can see it is e to the 7.118 power equals 1, 2, 3, 4. Now, FYI, they are never going to give you something that does not make sense. So, like, if you're like, I don't know if I switch that around right, literally type in e to the 7.118 power and see if it comes out to be that. Because I will never make you switch something around that's not nice. Because it's a decimal off because this number's rounded, smarty pants.
Are you in a bad mood?
No.
Did this come from Sunday?
I knew somebody was going to do that.
Behaving?
Sure.
I've
Okay,
heard that.
this is now a log. We got to make him exponential. What's the base?
10.
10. I'm going to put a 10 there. 10 to the y equals ax plus b. These are nice. Like, don't screw these up because these are free points on the test, right? Like,
should do,
don't
like,
screw that up.
Can you do a whole page of these?
Yeah, like, can we just do a bunch of them?
Yeah, can we just, can the whole test just be these? I will
Just those? Just
Yeah,
those on the whole test?
That would be
You
like
know.
the only test I get 100 on.
Right, there you
That
go.
really would be my only test that I really
Or you screw the top one up and then the rest of them are all screwed up and then you really do bad.
I'm
Don't
probably the
screw
only
these
one to
up.
do that.
These are like the easy ones.
Can we go to like 29 today and then we just have like word problems tomorrow?
I don't care. Sure.
That's a lot.
Okay, 18.
Those are
This
easy.
one. Okay, all right, here we go. Write the given expression as a single log. We're trying to put stuff together. All right, now here we go. How many pieces do we have right now?
1, 2, 3.
1, 2, 3. They're all ln's, right? Okay. And plus means multiply, and minus means divide, right? Okay. But before I add and multiply and divide and all that stuff, there's one number that needs moved.
3.
The last 3, right? The last 3. Where does he go?
To the back.
To the back. We never want to have numbers in front of our logs because we can put them to the back. Okay. So that 3 is no longer there. Got it.
What
What?
if they're all the same number?
What?
Like, what if all the, like, if we have numbers in the front,
No.
and they're all the same number?
Nope. Don't cancel them.
Don't cancel.
Nope. Because like you could have an x and a y and a z here or whatever, so that would be like x to the third, y to the third, z to the third, and those don't cancel off when you're reducing, right? Like that doesn't work that way. So no, don't cancel them. Now the only time that would happen is like, let's say you have 3 ln x equals 3 ln y, right? Then I could divide this side by 3, and that could go away if I have it equal to something, right? But you don't want to just cancel them all if they're all on the same side and stuff, okay? All right, so plus means multiply. So I'm just going to combine these two. This one, this one. What things are we multiplying?
3x.
3x times 3y. What is 3x times 3y?
9xy.
9xy. Okay, so I've got 9xy. And then I'm gonna like really write this out in baby steps, okay? So we got 9xy. Got it. I'm going to put that in parentheses. Minus ln x to the third power. Okay. Like if your brain can handle doing it all at one shot, go for it. But I just did the 2 combined, and now I'm going to combine the third one. Minus means divide, and you are dividing the stuff. So ln of what?
9xy.
9xy over x to the third. Done?
No.
No. I can cross out an x, right? Like this x can cancel with one of these to make that 2. Okay, so let's write in pretty. ln of 9y over x squared. That's better. He is a single log now. All of the good things, right? Was that difficult? Not terribly. Okay. If you can skip steps, go for it. Just make sure you're not wrong. Okay. All right. Okay, number 19. We had one similar. This might be actually the same problem that you guys had on homework assignment. The goal is to combine them as a single log, but I have e's and ln's going on at the same time here. So I'm going to be a little counterproductive, a little bit. I'm going to take these two, and rather than combining all of the stuff together, I'm going to split those two apart, just real quick, okay? These two, if I split them apart right here, this is multiply, right? But multiply means add. So I have ln of e squared, and then I have ln of x, and what's between them? Plus, right? Okay, all right. So there's that. Now, what happens to ln of e squared? Ln and e cancel, so this is just 2 plus ln x. Got it? Does that make sense?
What?
Yeah.
The 2 goes out in front. And
The
the
two,
element
like
of
the
E-
2 basically comes down in front, and ln and e cancel out to be 1. So this is like 2 times 1, which is just 2, right? Ln and e cancel each other. Okay. Okay. Then this one right here is, we're going to be counterproductive again. We're going to break apart rather than put together. So ln of e plus ln y. Okay.
The element of E goes away.
But ln e goes away, but it doesn't go away. Don't forget. It has to be plus 1, right? Ln and e is plus 1. Okay. Plus ln y. And then don't forget your minus 3 on the end.
And then the numbers go away and you're...
Oh, look at that. 2 plus 1 minus 3 is gone. So I have literally ln x plus ln y. Now let's put it together.
So
What does plus mean?
What would you do if it didn't go away?
Yeah, what if you had a bigger number than that? Like,
What if it was, you still had the minus 3 at the end?
Then you would just say ln xy minus 3. Because you can't put, you can't combine this with this. In which case, like, the instructions would be wrong because you can't combine them as a single log then. Because, like, the number. But anyway, like that's how that would work. Like, you could not combine the 3 with the ln. Okay, so get rid of the 3 so you're not confused. So ln of xy is all that you have, right? Multiply, add means multiply. But the 3 and the 2 and the 1 cancel. Got it? Okay, so sometimes when you have ln's and e's, you have to be a little counterproductive and like break them down before you can shove them all back together again and reduce. Okay, don't forget the ln and e. When they cancel, they don't create nothing. They reduce and become 1. All right, because I can see a lot of you guys putting 0 in which case you would get 2 minus 3 and get negative 1 at the end, right? Like I see that being a thing. So don't forget that he does come out to be 1. Got it?
Got it.
Okay, backside.
Whoa, you said get to the
Yeah, but you
bottom of
know,
the
like,
Yeah, but we have time.
We
Do you
have
really
time.
want to do a whole page tomorrow?
yeah, we have some time. We'll do a few of these. We'll do a few.
Easy peasy.
And these are easy peasy. Translate the given. These are more. This is more of what you want. This is more of what you want. Okay, is this a log or an exponential function? This is a log. We got to make him exponential. So his base is 5 to the u equals
CD minus K.
CD minus K. And that's it. You're not solving for anything. You're just making him the other form. Okay? 20. I don't know why this is in a different section. Maybe just because the like bases are not 10s and e's. I don't know. 21. He is a log. We got to make him an exponential function again. Okay? So he is, what's the base?
D.
D to the
W.
W equals
UV.
UV. That's it. Now those ones are hard to see if your answer's correct because obviously you can't plug anything into your calculator, but whatever. Just make sure that you put everything in the right spot, okay? This is what they're going to test you on in about a month and a half when you guys take the ACT. Like they're going to see, do you know how to switch them around? Really specifically, they'll probably ask you questions like these. 22 through 29, they'll ask you questions like that on the ACT, okay? Which is a lot of switching around. So keep track of where your equal sign is. So 22. Okay, there's your equal sign. I can combine these two because minus means
Divide.
divide. Okay, what am I dividing?
X minus 3 divided by 4.
X minus 3, how do you do X minus 3 divided by 4?
X minus 3 over
X minus 3 over 4. It doesn't divide nicely, so you just leave them like that, right?
equal to 3.
Okay, equals 3, he's just chilling. Now what do you do?
Nothing.
Yeah, he's a log function right now, and my brain isn't thinking log, so let's make him an exponential. If you get stuck, make him an exponential function. This is 2 to the third power equals
X minus 3.
X minus 3 over 4. Okay, now let's solve. We can still solve. What is 2 to the third power?
8.
8. Am I going too fast?
No.
Nope.
Okay.
35.
Now, yes. Now,
8.
what?
Multiply 4.
Multiply the 4 over. I want to get rid of the fraction. Okay, what is 4 times 8?
32.
32 equals
X minus 3.
X minus 3. And then
Add the 3.
add the 3.
Oh yeah, I did do 35. The next, I was thinking
X
one
equals
below
35. Questions about that? Good, good?
Nope.
Okay. All right. You want to try some of these on your own?
No.
No? You're still like,
No, it
Let's
confuses
just
me
go.
when I try to do it on my own.
okay, here's my equal sign. What are you going to do? You lead me through this one. What's our goal? What are we going to do now?
Combine the LNs.
Okay, combine the LNs, because I see this plus and I say that means multiply, right? Okay, what two things are you multiplying?
X plus 4 and 5.
X plus 4 and 5. So we've got ln of
Can you
what?
just, like,
5x
distribute?
plus 20.
Yeah, sure. Let's go ahead and distribute. 5x plus 20. Okay, equals 2. Now what?
E to the second power is equal to 5x
Okay,
plus 20.
this is log base e, right? Okay, let's make him an exponential function. So we've got e to the second power equals 5x plus 20. Okay, I'll buy that.
Do you like use your calculator?
Yep. Yep, what is e to the second power? It's
Big
like,
number. I don't know.
that's not a big number. It's like,
7.389.
Minus 20.
okay, all right, so I'm going to write over here. 7.389 equals 5x plus 20. We're going to end up with a negative number, and that's totally okay. Minus 20 is like negative 12 something.
Negative 12.61.
Okay, equals 5x
Divided by 5.
and divided by 5.
X is equal to negative 2.522.
Something of that nature.
Yep.
Okay, he won't come out nicely. Like probably a little over half of the time he won't come out as a nice number. Okay, good? Happy with that? All right.
Whoa.
I mean, not happy with it, but you know,
That's a
we'll
lot.
do. Okay. All right, 24. Oh, my algebra kids are doing this right now. Can we just do like cross, cross, cross?
Yep.
No.
Wait,
Only
no.
one of them.
Multiply the-
You can only do one on each side, right? So what that means is that we've got to find a way, here's my equal sign, to combine these two. But we can do that, right?
You multiply.
Plus means multiply, so let's combine them. Log base 3 of multiply
6x minus 18.
6x minus 18. Got it. Okay. Now,
Log
that
4.
equals log base 3 of
4x
4x minus 8. Now can I cancel them?
Yeah.
Yep.
Yeah, if there's 1 on each side, let's do it. Cancel, cancel. And then it's just an algebra problem.
Easy.
4x minus 8 equals 6x minus 18. Got it. Okay. What would you like to move?
Add the 8, subtract the 6.
No.
What?
No.
You are
Add
a
some-
nut.
subtract the 4.
Then you have -10 and -2.
We
No,
don't care.
you
No,
don't.
you
You're
don't.
positive.
You got positives everywhere.
Positive, wait.
You got positive 10 and positive 2.
Yeah, duh.
And x equals, you are a nut.
X equals
Not a
5.
nut.
X equals 5.
Y'all are just in
I'm not
denial.
a nut.
You, whatever
It
you,
makes sense to do it the
you
other way.
do, you just have to have the x on the left.
18 plus, -18 plus 8, that just makes -10. You don't even have to think about that. You just take 8 away from 18. And it's,
Or 18 minus 8 is 10. That's what this is.
Yeah, that's the same thing.
You are a nut.
you just move it over.
Whatever.
You don't even just, your logic doesn't make sense to
You
me.
work left to right. That is how your brain works. It's
No.
left to right.
My brain actually
No.
My brain works
Nope.
in simple terms. In simple terms means
My
that.
brain only works in
If I can
positive
do
numbers.
it faster that way, then I'll do it that way.
Negatives.
Negatives just don't make
Whatever.
sense to me.
Whatever. Okay, Luke, you ready? Don't write this down, anybody.
I literally
Okay, what do you do
got something
first?
in negative numbers.
You
Subtract the
subtract the 25.
No, you
No,
don't subtract the 25.
Dumb.
You add the x squared, so you don't have any negatives.
Stop. My brain
No,
does
I'm
not
Ah!
comprehend.
Stupid pencil thing again.
Whatever.
You guys need to
Okay. All right.
can't.
Next,
Just
25.
negative
Where?
one.
Can you cancel?
You
No.
jerk.
Yeah,
Why not?
No,
I don't
put
know.
X
Put
squared.
Where?
And then
Okay.
cancel.
We gotta move the 2 first. This 2's gotta go to the back.
So, I mean, you can't use
X
it.
squared. So, ln x squared equals ln 25. Got it?
Now you cancel.
Now we cancel, cancel.
X equals 5.
X
No.
squared equals
Plus
25.
you not do that
minus
in your
5.
mind.
Now hold on a second. Just wait.
You
wait.
just wait.
Take the square root. X equals the square root of 25
Negative
is
5, 'cause you can't take
technically plus minus 5. Okay, let's
But
talk
you
about
can't take
minus
negative
5.
ln, so it can't be
If
negative
I
5.
try to
So it
plug,
has to be.
Two.
It has to be.
Right. if I try to plug a negative 5 back in, I'm taking ln of negative 5, which is
Doesn't
not
work.
a thing. So,
It is a thing, it just doesn't work.
sure.
Wait a minute.
X equals 5 is the only answer that you need.
Sure.
Wait, could that be technically right? Because it's 2 ln of negative 5. Because you can make the ln positive, 5 positive.
Oh.
2 ln of 5, or
Got
negative
him.
5. You can still do that. You just have to move the 2. Wait, let me put it in my calculator.
If you do the 2 first,
This is not a real answer.
It doesn't
but if
work.
the
It
2's
doesn't
down
work.
in front, it's not gonna work.
It doesn't work then.
No.
How's it did it?
Wrong. Also, up here, we got a negative answer for like 23. Check it. Negative 2.522. Is
So that
that
is
like
it.
is that like a real answer?
Does
No.
not exist.
Apparently
No,
not.
just
no
wait,
answer.
just wait. Negative 2.522. I am adding it to 4 and then taking ln of that. Will that work?
Well,
Is
yeah.
that legit? Yes.
Line squaring my
That
negative
one works.
5 make it
No.
positive.
Yeah,
No.
but you don't do it in that order, Kyle.
But you don't do it in that order.
The ln goes first. Duh.
Correct. Yeah. Okay. Good. So just 5 is the answer. All right.
What kind of order of operations is ln follow?
Not the soup.
26. 26 and 27 are a change of base. Change of base. Change of base. We got 2 and 8. 2 is here, 8 is here.
Yeah.
Can you make those to be the same number?
Yes.
8 is the same thing as 2 to the
Third.
third power, but then we got the 5 there. This guy is just going to chill and he's going to say 2 to the 5x power. So 2 to the third to the fifth.
I always change the wrong one.
5x
Correct.
Doesn't make sense. but-
Correct. Yep. My algebra kids do the same thing. Because they want to take one side of the equation and multiply by another 2. And I'm like, no, because you're multiplying this one by 2 and you're not doing anything to this one. Here, if you do it this way, you're just rewriting it, right? You want to just rewrite. You're not adding anything extra into it. Okay, so this is, if we cancel out our stuff, our 2's go away. We've got 5x equals 15. Then divide by 5.
X equals 3.
And x is 3. Got it? Whoa, I can't write.
Holy
X
smokes.
equals 3. Okay, got it? Good? Am I going too fast?
No.
I feel like I'm going really fast on some of these. 27. Can you make those be the same number?
Yes.
This, we're going to leave this as 9 to the x power. 9 squared is 81. How do I get 1 over 81?
Negative.
Negative exponents.
Negative.
9 to the negative 2 power would make him 1 over 81, right? Negative exponents flip him.
Squared pi.
Okay. So, oh, this one's actually really easy. X equals
-2.
negative 2. Hey, look at that.
I did it
Wait,
a different
what?
way.
That's okay.
Yeah, I was gonna say I did do it.
I took the logs of both numbers.
Yeah,
to get
that's
X
what we're going to do in
down.
the next problem. Yep.
Log
Okay,
of
so,
81
Now,
was
that
1.
process makes it really nice and easy, right? This process, when we have 5 and 7 as our basis, can we get those to be the same number?
No.
No, so what do you do?
Log of 5, or 2x log of 5.
Okay, do you use log or do you use ln? It doesn't matter.
Ellen.
You use ln, okay, sure, it doesn't matter. So we've got ln of 5
But it
to
does
the
on
2x
2x,
power.
ln
It
of
does
5.
matter on the e. That's why I always use ln instead of log. Okay, the 2x is going to come down in front. So I've got 2x times ln 5 equals ln 7. Then what?
Divide by ln of 5.
Divide by ln of 5. Okay, so that's gone. Divide by ln of 5. So 2x equals whatever that decimal is. What's ln of 7? Make sure you close your parentheses after your 7. And then divide by ln 5.
Divide by 2.
1.21.
So 0.41.
Okay, and then divide by 2, right? So x equals like 0.6 something.
What?
I don't know.
605.
0.605. Yeah? Got it?
I did it a different way. I think I did that wrong. Hold up.
Possibly.
Probably.
Possibly. Now, could you have done, could you have logged both sides on this problem and logged both sides on this problem?
Yeah.
Yes.
Sure, right? You would have probably had longer steps, but you would still have gotten the right answer. It's just easier to do the change of base. You'll have less steps, but you could have logged both sides and gotten. So if you're wanting to check your answer, well, I guess if you're wanting to check your answer, I would first plug the 3 back in for x. I wouldn't even check my answer using a log. I would do that. But if you're wanting to check your answer, you could ln both sides, whatever. Okay.
Number 27 is just like common.
29,
How can you not just do that?
27,
Yeah.
whatever, kid. 29, e is a base and 4 is a base. Can you get those to be the same number?
No.
ln of
No. ln both sides. Okay, so ln. Now the 3x technically comes down in front. So we've got 3x times ln e. But what happens to ln e?
both. Turns to 1 and goes away.
Turns to 1 and goes away. 3x equals ln 4.
Divide by 3.
Then divide by 3. Now make sure when you take ln 4 divided by 3, you close the parentheses after the 4. If it opens parentheses. ln of 4, close, because you're only taking ln of 4. Then you're taking that whole thing divided by 3.
0.462.
0.462.
I did that in my head, Kyle.
Okay, you did not either. Whatever.
Dunsies.
Okay, Dunsies. Got it?
But there's
We
still,
got
like,
3 problems left.
We still have tomorrow.
We got 3
Tomorrow?
problems left. Okay?
I hate this.
All right, because these are hard. These are the hard ones where you're solving for t and the exponents and stuff. Okay? Got it?
Bye, Jake.
Goodbye.